Okay, so let's see. Starting the cylinder problem, we have a cylindrical lump of clay on the wheel that has an initial shape. So I'll put all this initial stuff in black here. So at t equals 0, um, we have a cylinder with a radius of 10 inches, radius equals 10 inches, and a height of 4 inches. And then just to kind of picture it here, um, our radius there that changes over time, and um, our height that also changes over time. So, but at t equals 0, those are the dimensions. Um, Assuming no clay is lost, so no clay is lost means that the volume is not changing. So dV over dt, change in volume with respect to time, is 0. Um, and what else? How fast is the height of the lump changing? So let me write that we want to find dH over dt when. So how fast is the lump changing when the radius is 7.5 inches when radius, and that's 7.5, which is 7.5. I'm going to write that as 15 over 2 um, to make the calculations with regard to like not losing decimals later on. Just a little bit easier to work with. And given the radius is shrinking, so we have another rate of change. Radius is shrinking by 6 inches every 5 minutes. So here dr over dt, radius is shrinking, so the change in r is with respect to time is negative 6 inches every 5 minutes. Okay. And let's see, those are all the pieces of information. Now we need an equation to tie all these together. And it looks like variables that need to be brought together are the volume, the radius, and the height. And so for a cylinder, we know that the volume equals pi r squared h. And we'll go ahead and then take the derivative with respect to t of both sides of this equation. So the derivative with respect to t. So our derivative here is dv over dt equals, and then let's see, we need our product rule. The reason why we need the product rule is because both r and h are changing. So they're both functions. So derivative of pi r squared is 2 pi r dr over dt, because that's the chain rule, the derivative of the inside. Then we leave the h alone. Rest of our product rule is plus. Um, then we leave the pi r squared alone, and then take the derivative of h, which is dh over dt. So that part in red, that's our derivative. And now let's do a quick inventory of what we have and what we need. So I'm just going to highlight everything that we have. So dv over dt, we've got that. R, we've got that, because this is all happening at the final time. So you could maybe mark this as like the final. And that's the initial information. So let's see. We have R. dr over dt, we've also got that. H, we need to find H. So I'm going to kind of mark here a reminder that we need to find H there in purple. Let's see, R we've got. dH over dt is what we're looking for. So, so eventually we'll find that. So it looks like in order to make some progress, we need to find h, and then we'll be able to have enough algebra to get dH over dt. So in part 2 of this video, we'll find h.